So nice to see you guys so early in the morning. I know from Miami time, we're asking a lot of you. So we appreciate you coming to the breakfast and coming to see the Nacho Jeep concept from Mopar. And now we're going to present the 2019 Ram 1500, specifically the e-torque system. And that system it's called a mild hybrid, but it's not so mild. And Brian Spahn is going to take us through it. He's an engineer with Ram. And before that, though, we have our Ram representative from the Southeast Business Center. And Aaron Dean is going to talk to you about just what Ram sales are like in Florida. It's a good market for us, and so he can kind of brief you on a little bit of that. So Aaron, come on up.
Thank you. Good morning.
Good morning.
Thanks for coming. As all of you know, Ram is in the midst of launching our all-new Ram 1500. This is one of the most important vehicles to the company and to all of our success. Our recent Ram sales momentum has been highlighted by our ability to bring in new customers into our showrooms, as well as retain our current buyers. Ram sales nationally were up 9% year over year. In the Southeast, Ram sales were up 20% year over year. Now that's our best September that we've had since the Ram brand was formed in 2009. Now sales of the Ram 1500 were actually up 20% year over year, which is another Ram record. A lot of the Ram sales success and momentum that we have is all due to the all-new Ram 2015. The Ram 1500 is loaded with technology. From our 12-inch 4-seat Uconnect touchscreen, along with a host of best-in-class technology. Ram also offers the quietest cabin, along with best-in-class ride and handling. We've also made Ram longer and wider. We've also given Ram the largest cab in the segment, along with twice the storage capacity of all of our competitors. We're really excited about the e-torque technology in the Ram 1500. That technology allows us to have an increase in fuel economy of over 20%. Increased fuel economy in our Pentastar V6 and our legendary Hemi V8. From a towing and hauling capacity, we've also increased that by 20%. So if you think about the 2015 Ram truck, it's really a no-compromise truck. It's the perfect balance of power, efficiency, towing and hauling capability, along with refinement. Now the Ram mild hybrid e-torque technology, which is standard on our V6 Hemi Pentastar, we're really excited about that technology. And who better to explain how that works than our Ram lead powertrain electrification manager, Brian Spahn.
Thank you. Okay. Thank you. So today I want to bridge from the previous generation program to the current 2019 Ram 1500 product, and we're going to go through the e-torque system, and we're going to do that with the transition from our first product that we have. Can you hear me? There we go. The first product we introduced within the brand, which was the conventional Hemi V8, our legendary Hemi with 395 horsepower and 410 foot-pounds of torque. We then took that system and we moved that into a mild hybrid architecture with our second introduction to the product. And our final gasoline product entry, which is now a base product introduction with the mild hybrid activity, is our Pentastar upgrade engine. And we take those things, and you can see on the screen here, a number of parts and integrate them to those conventional powertrains. We have a 8-speed transmission, which has now got a Generation 2 upgrade for the controls. and the mechanical efficiency. And we mate those to the motor generator unit on the front of the engine and the power pack unit that is mounted in the vehicle interior cabin. To showcase where we have that activity in the vehicle, we've now taken advantage of the new vehicle with a space on the passenger side for the subwoofer, and on the driver's side, a place for our mild hybrid battery. This battery pack is now a multi-purpose device. It has both 12 lithium-ion battery cells in it, as well as a DC to DC converter, effectively making that our alternator for the product, stepping the 48-volt system down to the 12-volt system to power the conventional vehicle load. So how does this thing work? We're going to go through 6 customer experiences to describe the functionality that the eTorque system provides for the product. And the first one is auto stop. The next one we're going to go through is the e-roll assist. That's that first acceleration component transition from auto stop to auto starting. Acceleration and upshifting. The fourth experience, cruising speeds. The fifth, customer experience, deceleration and downshifting. And then, of course, the final phase, regenerative braking, bringing us back to the zero speed state. So in the auto stop, this is one of those areas where there's a lot of very technical content. And on the graph here, you can see an image of what that representation looks like. The aqua line is the trajectory of the auto stop that we have, making it a seamless transition from running to stopping. And the blue line is the actual speed response that we see during that transition. The graph below that is what the motor generator unit has to do to generate that smooth transition. So this is not just stop-start with clunky feel. This is a seamless activity where the real-time optimization of the stop profile is managed through the electric motor machine on board real-time as the engine is slowing down. We also have retained 12-volt system support through the DC to DC converter and the 48-volt battery. That allows us to have all of the interior functions stay at that optimal voltage and allows us to be able to have full power steering lock to lock and offers us the ability to then manage that in ideal conditions up to a 10-minute duration. We also have an optimized heating and cooling system that's integrated with the product because we have a conventional compressor and water pump in the system. The way you get heat and cooling is by using the engine in its rotation. So when the need is required for the interior comfort, the engine is then restarted for the system to manage the balance between comfort and fuel savings. In the Hemi V8, you burn about half a gallon an hour. And in an auto stop that's 90 seconds in duration, you save about this amount of fuel. And this is just from the auto stop portion alone. So the next phase that we have within the product is the e-roll assist. And this is where, can you hear me? All right. Sorry about that. This is where the engine is then restarted, much like the graph that we saw in the previous slide. That same behavior exists as we refire the engine. We do that with ability to see both the brake pedal and the accelerator pedal. So we anticipate the driver's demand for motion, and we turn that into the claims that we provided of supplemental capacity of torque in the first 70 milliseconds from that experience of the driver asking for motion. We move from no rotational activity on the engine through 130 foot-pounds of torque on the electric motor to the crankshaft on the Hemi and 90 foot-pounds on the Pentastar. We've now generated the engine back running. We then stage that for motion, where we generate the motion of the engine to the motion of torque to the actual rear wheels. And we do that in about 400 milliseconds, or equivalent to the human blink of an eye. So in a blink of an eye, we've gone from your foot's moved to torque to the tire, and then we transition to the electric to combustion handshake in that first half a rotation of the vehicle wheels as you start to move the vehicle down the road. And that's how we do a very seamless auto starting activity based on the driver demand for launching the vehicle. So the next phase that we have is in real-time efficiency operation. That operation and optimization that happens is done through the use of a real-time manager for efficiency on the electric motor. So it's not just sitting there, well, I need some recharge from the previous auto stop. It actually looks at where is the engine, where is the vehicle demand from acceleration, and optimizes the charging performance for the motor and the discharging performance of the motor, so that we have an opportunity to charge efficiently on the engine. And we do that as well across the shifts. So as you go from second to third gear, for instance, you have an opportunity to decelerate the engine from the previous gear to the next gear down through that transition. And that shift optimization is allowed through the use of the motor generator unit to help bring the engine speed down, picking up a little bit more efficiency during that transition. That offers us that energy recovery across shifts, which is another place we use the eTorque system for fuel savings. The next place that we do some optimization within the product is in the use of what I'm calling the parasitic drag reduction. So much like in your alternator-based system, think of it as like riding your bicycle. You got a little bit of a drag from a misadjusted brake on the tire. That's sort of like your 12-volt loads on your system where you're pedaling along and you got to power through that. The same opportunity that existed in the auto stop is a place where the right thing for the system may be to simply do nothing. So there's times where we turn the electric motor off and just use the stored energy in the battery to offer the highest efficiency for the 12-volt loads, and then we turn the electric motor back on so that we can charge at a more efficient combustion zone and a more efficient motor operation zone. That's one of the areas where during cruising there's expanded use of powertrain efficiencies through the use of our MDS system, our two-step lift and variable valve timing on the Pentastar upgrade, the cooled EGR in the Pentastar, and the increased compression ratio that that product offers, giving us those increases in technology for the performance content, the capability content, and the efficiency that the product provides. So the next area that we're going to talk through is coasting and fuel shutoff. That's not uncommon to many products in the industry, but this is another place where we have an opportunity to do a integration and refinement improvement beyond the conventional programs, where we use reduced pumping effort of the engine to offer opportunity charging for the electric motor during the initial deceleration. So this is that zone where you're not pushing on either pedal, you're just coasting down. That's a place where we now have an ability to capture energy and provide additional recovery without any decrease in the vehicle's deceleration rate, seamlessly providing a coast down feel that's natural with an enhancement in efficiency. We also go through the operation like we did on the upshifting portion on the downshifting side, where instead of turning the engine back on to help accelerate the engine from fourth gear to third gear, we can use the electric motor to assist in that transition, giving us an improvement in shift quality as well as leaving the engine off to enhance that fuel savings activity without turning the engine back on. So the last phase that we're going to go through is where all hybrids get the bulk of their value, right? To do all of those features in the acceleration and coasting side, this is where we recover the energy. And we do that in kind of three levels of the product. The first one is we start doing brake regenerative activity in that dead pedal zone of the brake pedal. So as you just very gently start to push on the brake pedal, there's a little bit of lash in the system, some wind up mechanically to get the friction material and compliance to the brake rotor taken up. That's an area where we use the brake sensor on the brake pedal to be able to then put torque to the transmission and through the drive line to the electric motor to be able to recover energy. So those very slow deceleration conditions, if you just use your foot a little bit on the brake, that offers you a pure eTorque version recovery energy activity. And it's ultimately a blended system. So as you push on the brake pedal a little bit further, we retain that additional torque that is generated from the motor generator unit. And we take that and push that then into the friction side so that there's a blending between both the electric e-torque component and the friction surface. And we do that through about 10 miles an hour, where we then seamlessly transition to the friction side, blending that out as a pure friction activity. So the last 10 miles an hour of the product is done with a pure mechanical friction element, offering you very minimal, if any, perception that any of these activities are going on. You can't really tell that we're hiding out there. And the last thing that I want to talk about is another function that is kind of cool to the vehicle. Much like your air conditioner bill at home has an off-peak and on-peak kind of electrical rate, we have a similar function within the vehicle that allows us to take the regenerative braking and offer some opportunity cooling to the radiator fan and engine control. And that offers us a place where, because the electrons are now cheaper to effectively pay that cooling bill, we can enhance the cooling efficiency of the product so that we can increase those auto stop durations because of that opportunity cooling, which we refer to as smart fan cooling. So in summary, the key messages here is in conjunction with the other Ram 1500 improvements, which we're including in the frame, the body mass reduction in weight, the aerodynamic improvements. We have improved the system efficiency and overall fuel savings by greater than 10%. The e-torque system works in harmony with our existing engine technologies, such as cylinder deactivation, variable valve timing, and fuel shutoff, to improve the performance of these systems and expand their use. One of the areas that I didn't highlight or touch on was through the use of the four-cylinder operation in our Hemi application, for instance. We have a weight, a shake weight on the frame on both sides of the vehicle here. And that off motion that exists within the engine being fired and then non-fired for each cylinder in the event, we add an actual shake weight to the system to cancel that out. And we do the same thing through the active noise cancellation system within the interior, which allowed us to expand that use of fuel savings technology and four-cylinder operation within the Hemi application. And finally, the e-torque system is a further step towards vehicle electrification, delivering improved fuel economy, drivability, while supporting increases in performance and capability and comfort. Thank you.